Okay, now we're going to talk about RBF kernels. We already talked about kernel trick, and we already talked about curse of dimensionality. In curse of dimensionality, we talked about how data points are going to be more and more separated as we add more features or more dimension to our data set. So now we're going to talk about RBF kernel. RBF kernels are mostly used for non-linear data set that have very complex relationship with each other, or generally complex relationships. We don't, RBF kernel can be used for anything, but since they are expensive, as in you have to use so much memory, the processing time is high, you normally don't use RBF, even though they are very powerful. RBF is one of the most powerful kernels, but you always want to choose a kernel that is more suitable for your actual problem. The way that RBF operates is that it's actually very similar to Big Bang Theory. Not the movie, but the actual Big Bang Theory. So the data set, when you have this complex data set that is tangled together, you're applying RBF kernel. So what RBF kernel does is take your data set to infinite dimensions. As we talked about in curse of dimensionality, when you're taking your data set to a very high dimension, what happens is your data starts separating and become more sparse. There's going to be more distance between your data. So in a sense, if you're using dimensions correctly, this is good for your data set because you're basically untangling and making more linear relationship. And that, okay, if I take my data set to infinite dimension, then the space between my data set, the space between my data points are going to be infinite. But that is not correct, because at one point your data is going to be, okay, I am like the rest of the dimensions that you're adding right now, it's not relevant. So it's not going to, they are going to separate to a certain point, but they're not going to separate more than that. The dimension, the space is still expanding, okay? But your data set, after it's separated to the certain amount and then continuing to expand dimensions, doesn't have any effect on it anymore. They're going to travel into this expanding space together. RBF kernel is localized. So it look at localized places. So it will locate your data set wherever it is in this infinite dimension, and it just focuses on your data set. So now that we reach the maximum space between our data points, it comes and it tries to measure and see the similarity between these points. Imagine it's like circles that you are creating around every data set, and then it will figure out which data points are in that circle and or in that radius. So then it would say, okay, so these two are very similar, they can't be in the same category. It would give a score of how similar these 2 points are with each other. And then the way it does it is with exponential decay. The more separate your points are getting, the more irrelevant they become. But RBF kernel is not actually taking your data set to infinity. It is actually measuring the Euclidean distance between 2 points that you have, not in infinite dimension, in the actual dimension that you are at right now. But instead of just saying, okay, these 2 points are close together, so we're going to say that these 2 points are similar. And then these 2 points are far away from each other, so we're going to say that these two are unsimilar. So why is that not going to work? Again, because your data set is not linear. You can't just have a boundary between the similar data and unsimilar data. Instead, you're using exponential decay. Exponential decay doesn't give you a line. It will give you a curve. That is why it's like using the exponential decay is very similar to actually taking your data set to infinity. And then your RBF is asking you for a value which is called gamma. So gamma shows you how fast you want your similarity to be decreased. So basically mean if your gamma is a small number, the area, the radius that's going to be covered in your data set is going to be bigger. So that means more points are going to be in the same group, or more points are going to be considered similar. But the bigger the gamma is, that means that the radius of this gradual circle that you're creating around your data is going to be smaller, and the less data is going to be held in this, is going to be considered similar.